Hey guys, this video is 7-3 part 1. We're going to cut 7-3 into 2 days, day 1 and day 2. We're going to be multiplying and dividing rational functions. So today we're going to be multiplying. The next video, which would be day 2 or part B or whatever you want to call it, will be dividing rational functions. Most of you that have a problem with this section will have a problem with one or two things. This section is not hard. There's no real new math that we're doing here. But for those of you that'll have problems, it's because you're not confident with factoring yet. You're struggling with factoring still. If you're struggling with factoring, this will become a problem here, which is why we just reviewed factoring. And then another problem you may have is just the basic properties of fractions. But with that said, let's get started. So one thing I do want to go over, just basic properties of fractions. You guys should know this, but I still have a lot of people do it. You absolutely 100% cannot cancel out pieces or parts of addition and subtraction. So what I mean is, if you have, I don't know, 3x plus 5, whatever, and this is a fraction, so this is 3x plus 5 over just a 3. Okay. What a lot of people like to do is they see this and they say, oh, look, we have a 3 and we have a 3. So let's cancel that out and we're just left with x plus 5. Okay. This is not accurate. You cannot do this. Don't do it. Okay. It has to be a complete factor of both the numerator and the denominator. All right. So Miss Slayton went through and redid some of these notes to make it a little bit easier, since we don't have a good way to record without going up to my classroom, and they're really putting the hammer down that we can't go to our classroom. So she made this a little bit easier, so feel free. You may have to like pause it more or whatever, but that's fine. So if we're simplifying just rational expressions, so here's a fraction, here's a rational expression. The first thing we want to do is we want to factor this. So we're going to factor the numerator first. And when we factor the numerator, x squared minus 4x minus 12 just becomes x plus 2 times x minus 6. Remember, we want two numbers that multiply to a times c that add to b. So that gives us x plus 2 times x minus 6. And then we're also going to factor the denominator. Notice this is a difference of squares. So we're left with just x plus 2 times x minus 2. All right, when I look at this, you should notice that we have an x plus 2, that we have an x plus 2 here, and we also have an x plus 2 here. So now is when we can divide out these common factors. So when I do that, essentially x plus 2 over x plus 2 is just 1. Anything multiplied by 1, we don't even have to worry about it. So I can cross out the x plus 2 and the x plus 2. And then from there, all I have to do is simplify this fraction. So my final answer is x minus 2 over, x minus 6 over x minus 2. Now, one thing you do need to worry about, now remember back, you should know this, we cannot have the denominator of a fraction ever equal to 0, ever. The world will explode if the denominator of a fraction will ever equal 0. So cannot happen. So what I want to do is I want to go through these fractions. I want to say, okay, so what numbers would make my x equal 0? Well, here, if my x is negative 2, so x cannot equal negative 2. If my x is negative 2, then negative 2 plus 2 would equal 0. 0 times whatever here would be 0. The denominator would be 0. Cannot happen, okay? And then it's the same concept as if we do it here. X minus 2, okay? So if my x is equal to 2, then 2 minus 2 would equal 0. 0 times whatever over here is 0. We'd have a denominator of 0, which we cannot have. So in this problem here, I would say that x cannot equal to 2 or to negative 2. Now, this is one of my biggest pet peeves about big ideas. I know I've kind of ranted in class about things that I hate about big ideas. I love it. I don't want to say it's all bad, because there's some great things in big ideas, but there's just a few things that just get on my nerves, and this probably tops it all. All right, now big ideas says that because this is our final answer here, that the reader can assume that x cannot equal 2. Because if we put 2 in here, the bottom of the fraction will be 0. So when you're putting these in the answer, big ideas will exclude this 2. Okay, it's only basically the x's that you cancel out that equals 0. Now, if we were in class, I would tell you that you have to have this on your test, you have to have this on your quiz, you have to have this everywhere, or I will take off points. I guarantee you every other teacher would say the same thing. But since we're doing it at home, I guess you do have to still. Just don't put it in when you put in big ideas, okay? All right, so let's do another example. This is just when you multiply rational expressions, you multiply the numerators, you multiply the denominators, and then you simplify. Here's another example. We'll work through one where we do this. All right, so the first thing we want to do is we want to multiply straight across. We want to multiply the numerator. Okay, so 8 times 7 is 56. Remember, x cubed times x to the fourth. When we're multiplying, we add the exponents. And think of this as x to the first times x to the third. So we would just get 56x to the seventh, y to the fourth. Okay, now we're going to do the same thing with the denominators. Okay, so we do the same thing with the denominators. 2 times 4 is 8. X times nothing is x. Y squared times y is y to the third. And then from here, we take our likes terms and we just simplify. We use the properties of exponents and simplify. Okay, so 56 over 8, guys, that's our 7. X to the 7th over x. Remember, we subtract when we're dividing, so that's x to the 6th. Y to the 4th over y to the 3rd is y. And then once again, our x and our y cannot equal 0 because if they did, we'd have a denominator of 0. All right, multiplying rational expressions. All right, these ones are a little more complicated, but not bad, just a little more factoring. So when I see something like this, the first thing I want to do is I want to factor everything I can, essentially. So this first term here, if I factor on the top, all I have is a GCF of 3x, so it's be 3x, 1 minus x. X squared plus 4x minus 5, that factors to x minus 1 times x plus 5. All right, so when I do the same thing over here, x squared plus x minus 20 is x plus 5x minus 4 over, well, 3x doesn't factor. All right, well, notice I have an x plus 5 and an x plus 5 and a 3x and a 3x. So what I'm going to do is I'm going to take those and they will cancel each other out. So x plus 5 goes away, 3x and 3x goes away. I'm left with x minus 4 on top, a 1 minus x on top, and then I went a little far, an x minus 1 on top. All right, now I want you to notice that 1 minus x and x minus 1 look very, very similar. Okay, so we're going to use our critical thinking skills here. If I take this 1 minus x and I factor out a negative 1, okay, so if I factor out a negative 1, well, 1 divided by a negative 1 would be a negative 1. And then negative x divided by a negative 1 would just be a positive x. Okay? So 1 minus x is the same thing as this. If you don't believe me, distribute this out and you'll see. All right. So from here, I'm going to rewrite this inside, okay? So I'm going to keep the negative 1 outside. And I can just rewrite this as x minus 1. It's the same thing. I just flipped the order of the negative 1 and the x. Now, notice the reason I did that is because now I have an x minus 1 and an x minus 1. So that kind of brings me to my next step. So I'm going to substitute this negative 1 x minus 1 in for 1 minus x. Okay, so that's all I did. And when I do that, notice now the reason I did that is because Now I have x minus 1 and x minus 1 that go away. And so I'm just left with negative 1 times x minus 4. And then last but not least, I just want to distribute that negative 1 through. So I'm left with negative 1 plus 4. And then I want to go back into all of these. Okay, so if I go back up to here, my x cannot equal negative 5. Here, my x cannot equal 1. And here, my x cannot equal to 0. Come on. Okay, apparently it doesn't want to work. So negative 5, 0, and 1 is what my x cannot equal. All right, let's do one more example and then we'll stop and then I'll do a different video for day 2. All right, find the product here. Now, a lot of you in class will look at this and cringe until I put this over 1. And then you'll be like, oh yeah, that's not bad. So we're going to do this the same way as we just did the one before. So the first thing we're going to do is we're going to multiply the numerators, okay? Well, this can't factor, so that makes our life easy. So we're just going to multiply them, keep them in parentheses, don't factor them out. You're going to be making yourself miserable if you do. And then the denominator, notice this is the difference of cubes. So we're going to factor that out, okay? So x cubed minus 27 goes to x minus 3 times x squared plus 3x plus 9. So when I talk about difference of cubes, my a is my x, my b is my 3. And so we'll end up getting this. Well, we like this because notice this and this are the same thing. Okay, so we can divide out like factors. And when I do, I'm left with x plus 2 over x minus 3. And in the real world, not in big ideas world, but in the real world, I'd say x cannot equal to 3. And notice that x squared plus 3x plus 9, there are no real numbers that make that 0, so you don't have to worry about that. But big idea, since this x minus 3 is in our denominator, our final answer, you don't have to put this, but only in big ideas. It is still a thing. All right, we will stop there. The next video will be over day 2, where we will divide out the fractions.